After a 7-month journey, NASA's Mars rover is just hours away from a nail-biting landing.
When NASA successfully landed its Perseverance rover on Mars.
Its mission? To search for signs of life.
NASA took a gamble like never before, dropping a massive robot onto Mars with a flying crane. One mistake and the entire mission would have ended in disaster. But against all odds, Curiosity touched down safely, rewriting space history. It found proof that Mars once had water, even lakes and rivers, places where life could have thrived. But then came the real shock. It detected methane, a gas linked to life on Earth. Tune in because this mystery is only getting deeper. How NASA landed a rover like never before. Curiosity's landing wasn't just another space mission, it was a bold gamble. Scientists at NASA's Jet Propulsion Laboratory ditched traditional methods and went all in with a never-before-tested sky crane system. Picture a hovering platform, jet firing like a tiny spaceship, lowering a massive rover gently onto the Martian surface with cables. The risks were sky-high, but when Curiosity landed smoothly in Gale Crater, it was a victory like no other. And that was just the beginning. But as Curiosity roamed the Martian surface, one discovery would shake everything we thought we knew about the red planet. Gale Crater wasn't just any old dusty pit on Mars. It was a window into the planet's deep past, a time capsule hiding secrets in its layers of rock. At the heart of the crater stood Mount Sharp, a massive peak filled with history. The lower layers had minerals formed in water, proof that Mars wasn't always a dry, desolate wasteland. As the layers climbed higher, they showed how things changed, from a planet with lakes and rivers to the cold, lifeless world seen today. Scientists saw Mount Sharp as a jackpot of knowledge, and Curiosity was the key to unlocking it. The moment Curiosity hit the ground, it got straight to work. It started snapping photos, checking its instruments, and exploring its surroundings. The worry that Martian dust might mess up its gear turned out to be nothing. Everything worked, and Curiosity was ready for adventure. One of its coolest tools? A laser-blasting gadget called ChemCam. It could zap rocks and read the light that bounced off, figuring out what they were made of. The first test was on a rock named Coronation, and the laser was so hot it could outshine the sun's surface for a split second. Curiosity wasn't just about shooting lasers, though. It drilled into rocks, scooped up soil, and even baked samples in its onboard oven. One of the biggest surprises? Methane. Not a lot, but just enough to raise eyebrows. On Earth, methane often means life. Microbes deep underground, cows doing their thing, even decaying plants. But on Mars, no one knows for sure. Maybe it's from buried life forms long gone, or maybe it's just the planet's chemistry playing tricks. Either way, it was a mystery that made scientists rethink everything they thought they knew. As Curiosity climbed higher, it kept finding more proof that Mars once had lakes and rivers. Imagine a planet where water once flowed freely, filling ancient valleys and leaving behind clues in the rocks. Billions of years ago, Mars might have been a place where life had a shot. Not little green men, but tiny microbes, the kind that thrive in extreme places here on Earth. Curiosity painted a picture of a world that was once alive in ways never imagined. Of course, the journey wasn't always smooth. Mars wasn't kind to Curiosity's wheels. Sharp rocks tore through them, leaving holes and cracks. Engineers had to get creative, tweaking the way the rover moved, finding less dangerous routes, and keeping it rolling long past its original mission time. Curiosity was built to last just a couple of years, but it kept going strong, outliving expectations and making new discoveries along the way. Before Curiosity even left Earth, NASA ran it through brutal tests. Engineers put it through extreme conditions, making sure every part could handle the worst Mars had to offer. Parachutes were tested under insane speeds, radar systems were flown over Mars-like deserts on Earth, and every piece of the rover was checked, double-checked, and checked again. When the time came, all that prep work paid off. Curiosity not only survived, but thrived, paving the way for future missions like Perseverance, which is now on Mars, hunting for signs of ancient life. 15 years after launch, Curiosity is still out there, rolling across the red planet, uncovering its secrets one rock at a time. It's not just a machine, it's a pioneer. Every time it drills into the ground or zaps a rock with its laser, it's bringing closer to understanding a world millions of miles away. Even in its early days, it left a mark, literally. When it rolled across the dusty surface, its wheels stamped out the letters JPL in Morse code, Mars rocks that hold the key to life. Curiosity's robotic arm has been a key part of its success. Equipped with tools like the hand lens imager and the alpha particle X-ray spectrometer, it's a mobile lab that can analyze rocks and soil in incredible detail. One of its early targets was a rock named Jake Matijevich, after a NASA engineer. The analysis showed that the rock was volcanic in origin and likely formed in the presence of water. These findings are crucial because they offer clues about whether the planet could have supported life in the past. Over time, Curiosity's discoveries have painted a clearer picture of Gale Crater. Rivers once flowed into a long-standing lake there, leaving behind layers of rock and sediment that preserve the history of these ancient waterways. The rover's onboard lab studied the thin atmosphere and found evidence that it was much thicker billions of years ago. A denser atmosphere could have held liquid water on the surface, but over time, solar winds stripped it away, leaving behind the cold, dry world we see today. At Yellowknife Bay, Curiosity found rocks with features that hinted at a watery past, including tiny spherical formations called concretions. On Earth, these are often formed when water moves through sediment, leaving behind mineral deposits. Some scientists even speculate that similar features here are created by microbial life. Could the planet have once hosted living organisms? It's an exciting possibility that keeps scientists digging deeper. In 2013, the planet moved behind the sun from Earth's perspective, cutting off communication for about a month. NASA prepared for this by programming Curiosity with a list of tasks to complete on its own. Even without direct input, the rover continued drilling into rocks and capturing detailed images. As it climbed higher up Mount Sharp, it revealed more about the geological history. The mountain's layers act like a time capsule, showing how the environment changed over billions of years. Lower layers show signs of water activity, while higher layers reveal a transition to a drier, colder climate. Curiosity's findings have reshaped our understanding of Mars. It confirmed that the planet once had the conditions necessary to support life, even though no direct evidence of life has been found yet. The rover has also provided valuable data about Mars's atmosphere, weather patterns, and surface processes. Each discovery brings us closer to answering the big question: did life ever exist on Mars? And what does the planet's future hold? Even after 15 years, Curiosity shows no signs of stopping. Its instruments are still in good condition, and its mission continues to inspire scientists and engineers. As it climbs higher on Mount Sharp, the rover is laying the groundwork for future missions that might one day bring humans to Mars. The red planet still holds many things, but thanks to Curiosity, we're closer than ever to uncovering them. Every part of Curiosity's path, from navigating rocky terrain to analyzing ancient lake beds, has added a new chapter to Mars' story. Take Whale Rock, for instance. This formation shows how water ripples slowed as they flowed into an ancient lake, leaving behind layers of sediment. These silt layers, stacked over tens of millions of years, reveal a repeating cycle of lakes filling and drying, rivers carving paths, and Mars' climate swinging between wet and dry spells. Each discovery is like a puzzle piece, slowly coming together to form a picture of a planet that's far more dynamic than we ever imagined. Curiosity's path isn't just about rocks and soil, it's also about understanding the risks future astronauts might face. By measuring radiation levels, the rover helps scientists assess the challenges of human exploration. Its weather station records temperature, wind, and humidity, providing a snapshot of daily life on Mars. These data points are crucial for planning future missions and ensuring the safety of astronauts who might one day set foot on the red planet. The rover's cameras have also captured breathtaking views of Mars' landscape. Panoramic shots show rust-colored hills, distant mountains, and endless skies that create a sense of vastness. These images remind us why we explore: to see what's out there, to push beyond the boundaries of our own world. Curiosity's mission is a testament to human ingenuity and perseverance, proving that there's always more to learn. Mars may be a harsh and distant world, but through Curiosity's eyes, it's a place of wonder and endless discovery. As the rover continues its path, It keeps uncovering new things and inspiring us to keep reaching for the stars. The work Curiosity started made way for a new rover that would explore even more and look deeper into Mars. Perseverance's bold hunt for life. Mars is one of those places that has captured human imagination for decades. We've stared at the red planet through telescopes, sent orbiters to take pictures, and even landed some pretty fancy robots there. But let's be honest, none of those missions really stirred up as much buzz as NASA's Perseverance rover. This car-sized explorer wasn't just sent to snap some photos or roam aimlessly. It was packed with gadgets and a mission to dig deep into Mars' past. The ultimate goal? To figure out if there was ever life on this dusty, rusty world, and maybe to pave the way for humans to set foot there someday. Perseverance blasted off from Florida on July 30th, 2020. Imagine packing for a trip so long that it takes 7 months just to get to your destination. And that destination is almost 300 million miles away. That's how far Perseverance had to travel through the cold, empty void of space. When it finally reached Mars on February 18, 2021, it landed in Jezero Crater, a spot that scientists were absolutely giddy about. Why? Because millions, maybe billions of years ago, Jezero Crater was likely a lake. Water means life, at least on Earth. So this spot seemed perfect for hunting down traces of ancient Martian microbes. Let's talk about the rover itself. This thing is massive, weighing over 1,000 kilograms and stretching nearly 10 feet in length. It's basically a lab on wheels. Cameras, lasers, drills, and even microphones. You name it, Perseverance has it. These tools weren't just for show. They were designed to scan, analyze, and collect Martian rocks and soil. But here's the kicker. Those samples aren't even staying on Mars. They're being packed into small, sealed tubes so that a future mission can scoop them up and bring them back to Earth. That's right. We're going to all this trouble to ship Martian dirt across space because studying it up close might finally tell us if Mars ever had life. Oh, and let's not forget about Perseverance's sidekick, Ingenuity. This tiny helicopter hitched a ride with the rover and became the first aircraft to fly on another planet. When it lifted off on April 19, 2021, it was a groundbreaking moment. Mars's atmosphere is super thin, about 1% as dense as Earth's, which makes flying there incredibly tricky. But Ingenuity pulled it off, proving that future missions could use drones to scout the terrain or even help astronauts navigate this alien world. Now, back to Jezero Crater. Perseverance has been busy exploring this ancient lake bed, checking out river channels, deltas, and crater rims. Every rock it studies, every sample it collects, adds a piece to the problem of Mars history. In July 2024, it came across a reddish rock with peculiar spots that scientists nicknamed Chayava Falls. These leopard spots sparked excitement because they could be signs of ancient microbial life. But as always, science moves slowly, and more testing is needed to confirm anything. While the hunt for life is fascinating, Perseverance isn't just about looking backward. It's also testing tech that could be crucial for future human missions. Take MOXIE, for example, a clever device that turns Mars's carbon dioxide-rich atmosphere into oxygen. Yes, you heard that right. Perseverance is literally making air on Mars. This is a huge deal because it shows we might not need to haul tons of oxygen from Earth when humans finally set up camp on the red planet. Perseverance's path hasn't been without challenges. Mars is a harsh place with freezing temperatures, dust storms, and rugged terrain that would make even the toughest SUVs struggle. But this rover was built to endure. It's been climbing over rocks, navigating tricky slopes, and surviving in conditions that would destroy most Earthbound machinery. Every day it spends on Mars is a testament to the engineering marvels that went into building it. Then there's the matter of communication. It's not like Perseverance can just pick up a phone and call home. Signals from Mars take anywhere between 5 to 20 minutes to reach Earth, depending on the planet's positions. This delay means the rover has to be pretty independent, using onboard computers to make real-time decisions about where to go and what to do. It's like giving a robot the freedom to explore a whole planet, a mix of thrilling and nerve-wracking for the scientists back on Earth. One of the most exciting aspects of Perseverance's mission is its role in the upcoming Mars Sample Return project. NASA and the European Space Agency are teaming up to fetch those sealed tubes of Martian rocks and soil. The plan is to send another spacecraft to Mars to grab the samples and bring them back by the early 2030s. If all goes well, these samples could answer some of the biggest questions we've ever had about Mars. Was it ever alive? What does its geology tell us about the planet's history? And perhaps most importantly, what does this mean for the possibility of life elsewhere in the universe? Perseverance's contributions go beyond science and technology. They've captured the public's imagination. People around the world have followed its path, cheered for Ingenuity's flights, and marveled at the stunning images and sounds sent back from Mars. It's a reminder that even in a world full of challenges, humanity can still achieve incredible things when we aim for the stars, or in this case, another planet. As Perseverance continues its mission, it's paving the way for the next era of exploration. Its data will guide future missions, whether robotic or human, and help us prepare for the monumental task of living on another world. Whether it's finding traces of ancient life or testing technologies for survival, this rover is setting the stage for humanity's next giant leap. And who knows, maybe one day humans will stand in Jezero Crater, looking down at the tracks left by this remarkable machine and thinking about how it all started. As Perseverance finds more on Mars, strange things on the planet still leave scientists with many questions. The magnetic past that Mars left behind. Mars has always been that strange neighbor in our solar system, full of surprises that keep scientists scratching their heads. One of the biggest questions is methane. On Earth, this gas usually comes from living things or geological activity. But on Mars, no one can say for sure. The methane levels aren't consistent either. They come and go, almost like the planet is teasing us with clues. Some think it's from microbes hidden under the surface, while others blame natural chemical reactions. Still, the lack of a clear answer makes you wonder, what's really going on beneath that red dust? Then there are those strange plumes that were spotted back in 2012. Rising 155 miles above the surface, they're way too tall for typical weather patterns. Dust storms? Maybe. Auroras? Possibly. But no one's nailed it down. Whatever's causing these sky-high phenomena, it's definitely not normal, and it's raising eyebrows about Mars's atmospheric quirks. Speaking of weird, let's talk about the so-called spider formations. Found in the southern regions, these creepy web-like shapes appear when carbon dioxide ice sublimates, carving out strange channels in the dirt. It sounds simple enough, but the exact process still isn't fully understood. What's causing the ice to behave this way, and why only in certain places? The answers remain elusive. And these spider-like patterns are just another reminder that Mars likes to keep its questions. And how about Mars' split personality? Its northern hemisphere is all smooth plains, while the southern half is rugged and covered in craters. It's like looking at two different planets smashed together. Scientists suspect a colossal impact billions of years ago might be the culprit, but evidence is thin. If it did happen, why hasn't more proof turned up? The planet's history seems to be written in code, one we've yet to crack. Mars' magnetic field, or lack of one, is another head-scratcher. Instead of a protective shield like Earth's, Mars has scattered magnetic patches across its crust. These suggest the planet once had a global magnetic field that strangely vanished billions of years ago. Why did it disappear, and what does that mean for any life that might have existed there? It's a haunting question that no one's been able to answer. Then there's the riddle of those seasonal dark streaks on Martian slopes. Known as recurring slope lineae, they show up during warmer months and fade when it's cold. At first, it seemed like flowing water might explain them, but newer studies lean toward dry, sliding grains. Either way, these streaks don't fit neatly into any known explanation, leaving scientists guessing. Let's not forget the towering dust clouds discovered by the MAVEN spacecraft. These clouds hang out at heights between 93 and 108.6 miles, defying expectations in an atmosphere so thin. What's kicking up dust that high, and why? It's just another unsolved piece of the Martian question that keeps experts on their toes. Mars may be our closest planetary neighbor, but it's anything but simple. From its bizarre atmospheric events to unexplained geological features, the red planet continues to challenge everything we think we know. Are these questions clues to past life, hidden processes, or something entirely unexpected? One thing's for sure, Mars isn't giving up its answers easily. Is Mars truly a barren wasteland? Or could this footage hint at life NASA isn't ready to confirm? Share your thoughts and don't forget to like and subscribe for more.